everyone. This video is another video of us discussing the design pattern in software engineering. In this video, we will present to you the singleton pattern. About the singleton pattern is a design pattern that ensures a class has only one instance, provides a global point of access to it. So let's dive into this singleton pattern. This is my team, including Frank and me, for comment. So first of all, I will give you an example to have a clear view about what exactly singleton pattern we talk about. So for example, let's say we have a class that represents a printer. We want to ensure that there is only one printer printing a document so that we don't end up with multiple printers printing the same document. So to tell the machine that only one printer prints the document in here is we want to give only one command to one printer to bring out the document, the material we need. So we don't end up with these 4 printers printing the same document. So we need some kind of method, some kind of to help us to deal with this kind of. So this is called the singleton pattern. So the singleton pattern is to ensure that there is only one instance of a class while providing a global point of access to this instance. This can be useful in situations where we want to ensure that only one instance of a particular object available for us to use, such as a database connection, a printer, or singleton pattern. We might end up with multiple instances of a class, which can lead to issues such as inconsistent behavior or wasted resources. So, for the singleton, I will give further explanation about the singleton pattern. So to set up our program based on the singleton pattern, we use a private constructor to ensure that the class only be instantiated once and a static method to provide global access to the instance. This is achieved only by using a private constructor. The way to implement this one, I will go on to the next implementation part. So this is the code of mine. So in this code is about the problem I have mentioned before, about the printer problem. So for example, in here we have 4 different printers. So we want one of it printing the document, the material. So here to implement it, we will need only one printer. Here I use private constructor and privately constructor to prevent instantiation from outside. In main function, we cannot call a printer B like this because it will be Android, as this constructor is a private one. And for privately constructor is this printer instant will exist until the program finish. Then so because I use private constructor here, so we cannot instantiate from outside. So how can we get the instant one? So we can use this method in public here to get the method we want. So by declare this and this is the way we initialize our printer. After that, when we have the printer here, we can use the function. So printer.read hello world, and this will call to this function here. finally, this one is to destroy instance. So whenever we don't need the instance we exist, still want the program to go on, then we can use this destroy instance. And finally, this two lines is for delete copy constructor, and to prevent the duplication in our program, to prevent two or more instance in our program. So next is the advantages of this singleton pattern. So the singleton pattern has several advantages, including first, ensuring that there is only one instance of the class. Two is to provide a global point of access to this instance. The third is allowing for lazy initialization of the instance. Then finally is allowing for thread-safe access to the instance. For example, let's say we have a class that represents a database connection. We want to ensure that there is only one instance of this class. So that we don't end up with multiple connections to the same database, we can use the singleton pattern to ensure that there is only one instance of the class, and that instance is globally accessible. This allows us to ensure that there is only one connection to the database and improve the performance, at the same time reduce resource usage. Then next, the disadvantages. So first one is violate the single responsibility principle. The pattern solves two problems at a time. Second, the pattern requires special treatment in a multi-threaded environment so that multiple threads won't create a singleton object several times. Then the third, the single pattern can mask bad design. For instance, when the components of the program know too much about each other, it may be difficult to unit test the client code of the singleton because many test frameworks rely on inheritance when producing mock objects. Since the constructor of the singleton class is private and overriding static methods is impossible in most languages, we will need to think of a creative way to mock the singleton. So, as I've mentioned about the definition, the implementation, the advantage of this advantage of the singleton pattern. Now this is the end of our presentation. Thank you for listening.